Alright, now in this video we'll be talking about graph plotting, and here I have my graph paper and I have my table of values. So I'll just explain the table of values briefly. Now this table of values we actually gotten from an experiment using a G clamp. Now on this table of values here we have the initial displacement, that's when the G clamp was placed at the 40 cm mark. The initial displacement you have on the meter rule is 36 cm. Here we have 36.9 cm when the G clamp was placed on the 60 cm mark. For these two positions, no masses were added. Alright, now this is where we now have the masses to be added to the setup. Here we have 100 grams mass added. You have a new position 36.9. Now to get the Y value you're going to be using here in your formula, you always say 36.9, which is the value you're going to get, alright, on adding 100 grams minus the initial value for 40 cm mark. This is for 40 cm mark, so you go to the initial value you had for 40 cm mark. That's what you're going to get here, and this is what you're going to use in your plotting. You come here to the 200 gram mass, the same thing again, 37.5 minus the initial value. On adding the 200 gram mass, you're going to have a new position which is 37.5 minus the initial position, which is 36 cm. You write it down here. You do the same thing for 300, for 400. You always subtract from your initial value. The same thing here. You always subtract from your initial value. So you can make out time, or you can pause the video and try to understand the table of values better. Now let's come back to our graph. Now in graph plotting, the first thing you always do in your graph plotting is to draw your axis. Alright, you draw your axis. Now you need to understand that your graph needs to be as big as possible. All right, it needs to cover at least 2/3 of your graph paper. All right, your graph has to cover at least 2/3 of your graph paper. This is just to reduce the chances of errors and all of that. All right, so very small graphs are not permitted in graph plotting or in physics graph plotting. You can see, yes, look at my graph paper here, and then look at where the whole of this is my graph paper, and then look at my axis. I have my vertical and my horizontal axis, and you can see it's covering almost everything on the graph paper. So that's how it's supposed to be. So the first thing you need to do in graph plotting is to draw your axis, the vertical axis and the what? Horizontal axis. Now in this question, or for this graph, we are going to be looking at plotting a graph of M against Y for L equals 40 cm. So here we'll be working with the L equals 40 cm part. We'll forget about the L equals 60 cm part, though the graph for this question, or for this table of values, actually required you to plot M against Y. That's L, that you plot M against Y for L equals 40 cm, M against Y for L equals 60 cm, using the same axis. So I'm going to cover that one in a separate video, but this is actually our first video on graph plotting, so that's why I just want to take one axis on M and then one axis on L for better understanding. But in our next video or subsequent videos, I'm going to cover M against Y when you're looking at the two axes, all right, the two positions, or the two axes to be on just one axis here. All right, the two of them, the two values of Y, when you're looking at the two values of Y, to be on one axis. So let's start now. Now looking at what we have after drawing your axis, vertical axis and horizontal axis, which is the first thing you to do. The next thing you need to do is to label your axis. Now remember I said you're plotting a graph of M against Y for L equals 40 cm. So you label your axis, and what do you use in labeling your axis? You label your axis from what you're asked to plot. If you're asked to plot a graph of M against Y, all right, for L equals 40 cm, or let's say M against Y, it simply means your vertical is going to be M and your horizontal is going to be Y. All right, the first value they mention in the question will be for your vertical, and the second value will be for your horizontal. So if they say a graph of M against Y, M will be for vertical, Y will be for horizontal. If they say a graph of L against T, L was mentioned first, so L will be vertical and then T will be horizontal. Now we have M against Y, a graph of M against Y. So come down here, we label it. We have This is M axis. Now, as you label it, you also put the units. M is measured in grams here, according to the table of values. And then this is Y axis. Remember, it's a graph of M against Y. So we'll come down here, we'll label the horizontal also, which is Y, and it is in cm. So that's what we have here now. So we've labeled our axis. The next thing now will be to title the graph. Title the graph is very important. You do all of these things. So title. So what's going to be the title of this graph? You're plotting a graph of M against Y. So that's simply going to be the title. The title of the graph is simply going to be a graph of M in grams against Y in cm. So that's going to be the title of the graph. And then the next thing now will be to get your scale, the scale of the graph. All right, so remember step one, you draw and label your axis, M axis and Y axis. You attach their units. The next one will be to title. The title depends on what you're plotting. All right, so this is a graph of M against Y. Now the next thing now will be to get the scale. Now the scale, you're going to get scale for the vertical and then scale for the horizontal. Scale for vertical and scale for horizontal. So how do we go about the scale? Now there's a simple formula I usually use when I want to calculate scale, and the formula is actually based on the principle of interval, or based on the interval. That's by how much will I be increasing. That's just what the scale is all about. And that formula is simply, if I want to get the formula for scale, I'll first of all calculate my interval. So the formula now is actually interval equals the highest value minus the least value divided by the number of grid lines. So this is the equation I use whenever I want to calculate scale. I first of all try to get the interval. All right. Now the highest value I'm talking about is the highest value from your table of values, and the least value is the least value from your table of values, divided by the number of grid lines. The grid lines I'm talking about are simply the bold grid lines that we have here. The bold grid lines. All right, that's what I'm talking about here. On the vertical here, the bold grid lines we have here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I'll end it here. All right. So I said the grid lines are the bold ones. On the horizontal, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'll stop at 16 here. Okay. So this is what I mean by the number of grid lines. So please take it down or note it down somewhere. For the vertical, we have 14. For the horizontal, we have 16. Now, like I said, you're going to get scale for vertical and scale for horizontal. All right, and our vertical is M axis. So label it. Let's try to get scale for M axis. All right, now you don't need to write this in your manual, on your worksheet, on your graph. All right, you just do this on a separate rough sheet. All right, which you can discard later. So let's try to get the scale for M axis. Now remember I said scale here, I use highest. To get my scale, I get the interval first, and I use highest minus least divided by number of grid lines. Now we want to get scale for M axis. So we'll go to the M table of values, the column for M on the table of values. Now looking at the column for M on the table of values, what is our highest value here? Our highest value here is 600, and the least value is what? 100. So our interval now, let's try to get the interval for M axis. Interval here, the highest value here is 600, so it says 600 minus the least value here is 100, so say minus 100 divided by the number of grid lines. How many grid lines did we count for the vertical axis, remember, or M axis, remember it was 14, right? So we have 600 minus 100 over 14. All right, so we have interval now to be equal to, you can use your calculator to check this out. We have 600 minus 100 divided by 14. So that's around 35. We have 35.71. All right. Now this is going to serve as our lower interval. Lower interval. This is going to serve as our lower interval. So write it down here. This is for lower interval. Lower interval. Now to get our upper interval, we multiply what we got here by 2, our answer by 2, and that will give us 71.43. So we have upper interval. Upper interval. Now we have lower interval and we have upper interval. So what do we do with this interval? Remember, the interval is from 35.71, all right, towards 71.43. Lower interval, upper interval. This is what we have. Now, what do we do with this interval? We are simply going to choose a number between this interval. This interval is just a pointer of what your scale should be between in order to cover this graph very well. All right. So we are going to choose a number between 35.71 and 71.43. Now, the number we are going to choose is going to be a number that will be very easy for us to work with. In other words, it should be a number that is divisible by 5. I usually prefer numbers that are divisible by 5 because here you have, in each big box here, you have 5 small boxes. So to get the value of each small value here, we divide by 5. So I usually prefer numbers that are divisible by 5. So between 35.71 to 71.43, a very good number we can work with, or that can work very well here, is 50. All right, so we are going to be working with 50. That is going to be our interval. So our scale for the vertical axis is going to be increasing by 50. So we have 50. The next one here is going to be 100. The next one here is going to be 150. The next one here is going to be 200. And then here we have 250. Next we have 300. Next we have 350. Next is 400. Next is 450. And then we have 500, 550, then finally 600. So this is what we have for our vertical. So you can see it was able to cover everything on our vertical axis, or on our vertical column here. So this is our scale for the vertical. So what do we call this scale? Now each box here represents 1 cm. Each box here represents 1 cm. Each box here represents 1 cm. Each big box represents 1 cm. So from here to here is 1 cm. From here to here is 1 cm. So on our scale for the vertical axis, we say M axis. M axis. All right. M axis. This is going to be, remember this from here to here is 1 cm. So we say M axis, we have 1 cm represents, now what's the interval we have here? You can see that the difference for each one is 50. All right, 100 minus 50, 50, 50 minus 0, 50, like that. So the interval is 50. That's the number we chose. So say 1 cm represents 50. Now we don't say 50 units. What's the unit for the m-axis? That's what you're going to use here. So say 50 grams. All right. So the m-axis, the scale is 1 cm represents 50 grams. So that's how we get our scale. Now the next one is going to be for the horizontal. Just like we solved for scale for the vertical, we also solve for scale on the horizontal. All right. So how do we go about scale for the horizontal? We use the same formula, the same interval principle. Now using the same interval formula to get the scale for the horizontal axis. All right. Now remember we are plotting m against y, but the y we're using here is the y for L equals 40 cm. That's what we're using here. So in other words, we're using just this column here. All right. So we're plotting this against this. So this is what we're plotting. So using our formula, we've gotten the scale for m-axis. Now let's get the scale for y-axis. So again, using our interval formula, we have highest value minus least value divided by the number of grid lines. Remember, we counted the number of grid lines for the horizontal to be 16. And then for the vertical, we had 14. So let's get our interval again. So we have interval equals, what's the highest value we have here for the horizontal that we want to plot here? The highest value is 4.3 and the least value is 0.9. So we have 4.30 minus 0.90 divided by the number of grid lines we counted, the bold grid lines we counted for the horizontal, which was 16. So we have 4.3 minus 0.9 divided by 16. 4.3, that will give us minus 0.9 divided by 16. That will give us 0.215. So again, this is going to be our lower interval. Lower interval. Alright, so to get the upper interval, we multiply the lower interval by 2. So we have 0.215 multiplied by 2. And that will give you 0.425. So we call this our upper interval. Alright, now this means your interval, or the best number to use as your scale, is going to be between 0.215 to 0.425. So take note of it, 0.215 to 0.425. So what's the best number to choose between 0.215 to 0.425? You can see I prefer going with 0.25 here. Alright, 0.25 will work very well. 0.25 can actually be divisible by 5. Remember I said go with a number that will be easy for you to work with and is easily divisible by 5. So 0.25 will work perfectly well here. Alright, we have 0.215, 0.25. 0.25 is greater than 0.215. So I'll go with 0.25. So each grid line here, alright, or each big box, each grid line, each bold grid line here is going to be 0.25 on my horizontal. So I come here, I put it down, I record it down, 0.25, 0.5 and the likes. So if we do that, we're going to have the first point here to be 0.25, 0.25, and then the next one here, the interval, remember, is increasing by 0.25. So if you add 0.25 to this, the next one here is going to be 0.5. You add 0.25 to this is going to be 0.75. add 0.25 to this is going to be 1.0. Add 0.25 here, we have 1.25. Add 0.25 here, we have 1.5. And add 0.25 here, we have 1.75. We have 1.75. And then here we have 2.0. We have 2.25. Remember, you keep on adding 0.25. Here you have 2.5. Here you have 2.75. Here you have 3.0. Here you have 3.25. And this is going to be 3.5. This is going to be 3.75. And then this is going to be 4.0. Alright, so this is what we have now. So what is going to be the scale for the horizontal axis? So we come down here, we write it y-axis. That will give you, each box here, remember, is 1 cm. So say 1 cm represents is 0.25 interval, increasing by 0.25. So say 0.25 cm. So that's going to be your scale for your horizontal and scale for vertical. So this is a simple formula you can use to get your scale. Alright, so we've titled the graph, we've gotten our scale. The next step is to start plotting the points one after the other. Alright, so now we are going to plot the points. We've gotten our title. We have our title, which is a graph of m in grams against y in cm. And then we have our scale in m. For m axis, we say 1 cm represents 50 grams. That's what we have here. And then for y axis, we have 1 cm represents 0.25 cm. So now let's plot our points. Now the first point to plot is for 100 and 0.9. Alright, so m is at 100, and then for y we have 0.9. So we're going to come down here. 0.9 should be between 0.75 and 1.0. Alright, 0.75 and 1.0. Now to get the values in between, alright, we divide the interval we have here, which is 0.25. This is 0.25. We divide the interval we have here, which is 0.25, or the first number we have here, which is still 0.25. Alright, the first number from 0, that's from the origin. We divide it by the number of grid lines we have in between, right, from 0 to this. Now it's supposed to be 5, though on this my graph paper it seems to be, I think you have 4 here, but then on your normal graph sheet it's actually 5. So you divide by 5. So from this to this, to get the numbers in between, you divide by 5. So we see 0.25 divided by 5, and that will give us 0.05. So it simply means each small box here represents 0.05. Now we are looking for 0.9. 0.9 should be between 0.75 and 1. Alright, so since it's closer to 1, we move down from 1. So if this is 1, the next one here is going to be 0.95. Alright, so we subtract 0.05 from 1. Since we're moving towards the left, we're moving downward. If we're moving towards the right, we'll be adding 0.05. So here we have 1 minus 0.05, that will give you 0.95. You subtract again, minus 0.05, I think that will give you 0.9. Alright, so 0.9 should be somewhere around here. 0.9. So we trace it down up to where we have 100, and then we mark it down. Alright, each small line here, each of those thin line, all right, we said it's going to be 0.05. Divide 0.25 by 5, you get 0.05. So each thin line here is going to be 0.05. So like I said, from 1, you subtract 0.05, you get 0.95. Subtract 0.05, you get the next one, which is what? 0.9. Subtract 0.05 from 0.95, which is 0.9. Then you mark it on the points where you have 100. Now the next set of points to plot will be 200 and 1.5. You can see those ones. We have 200 here. The 1.5 is actually very clear here, so we can trace them. 200 and 1.5, so we mark them as well. And then after this, we have 300 and 2.20. So we have 300 here, and then 2.20. To get 2.20, 2.20 is actually, okay, we have 2.25 here. All right, 2.20 will be between 2.0 and 2.25. So to get 2.20, we subtract from 2.25 downwards. All right, remember each thin line here is 0.05. So 2.25 minus 0.05, and that will give you 2.20. So 2.20 should be around here. Trace it up to 300. So we have this. We'll mark the point 300. And then the next point is 403.00. So we have 400, and then 3.00 is simply 3. This one can easily be gotten. So we have 3 and 400. Then we have 503.6. 503.6. 503.6. We're plotting M against Y. So where is 500? This is where we have 500. And then 3.6. 3.6 should be closer to 3.5. It's in between 3.5 and 3.75, but then it's closer to 3.5. So remember, each thin line is 0.05. The value of each thin line is 0.05. So from 3.5, we keep adding 0.05 till we get to 3.6. So add on the first one, 3.55. You add on the second line, that's 3.6. So it's going to be on the second thin line. So trace it upward, 3.6 to, we have 500. All right, so it's supposed to be around here. So that's what we have there. And then after this, we have 604.30. This is 600. And then we have 4.30. Now remember, this is 4.25. To get 4.30, you simply add 0.05 to this. So 4.30 is just around there. 4.30. You add, this is where we have 600. So you connect them. Connect to 4.30. 4.30 is just the next thin line after 4.25. Remember, each thin line is 0.05. So we have 4.30 around here. So now we've plotted our points. This is our plotted point. The next step now will be to get your line of best fit. Alright, so this is what our line of best fit is going to look like. Now, it is not a necessity that your line of best fit must carry all the points. No. The line of best fit is simply a line that, okay, it should be close to all the points. It's a measure of the data central tendency. All right, so it should be close to all the points. It's called a line of best fit. It should be close to all your points. In as much as you have points above the line, you should also have points below the line. Not a situation whereby you draw your line of best fit and the points that the best fit line did not carry are all above, or the points that the best fit line did not go through are all below. No. In as much as you have points where the best fit line did not pass through are above, you should also have some of them below. So that's why we call it a measure of the data's central tendency. All right, so it should be central to everything, should be close to all the points, as close as possible. So this is what it looks like. We'll plot our graph and then we get the line of best fit. Now in our subsequent videos, I'm going to show you how to calculate slope and error in slope.